Okay, so this is the whiteboard here, and we'll go over some basic concepts of one-dimensional motion. First off, your coordinate system and how you're going to measure distance and time is very important. So we'll start off with the coordinate system here, and first we'll do one end needs to be positive and negative, so that's going to be a positive end, and this is going to be a negative end. Okay, so there we go, one direction, and this is going to be, our coordinate for position is going to be x. Okay, and we need someplace to equal 0, so that's going to equal 0. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we'll say this is x equals 5 here. And this is x equals -5 here. Okay, so that's a basic measure, and you can think of that as like a ruler. I'll draw a little ruler here. So that's like a ruler with tick marks here. And so if this was like a regular 1-foot ruler, it would have 12. So that would be 12, and so that would be in inches. Usually we measure it in meters. So what kind of motion would this describe? Well, one example I like is if we just have a rod and we have a little bead on it like that. So then it's constrained to only move in one direction or one dimension. We call that degree of freedom. So we only have 1 degree of freedom. And then in time, it's going to move along this like this. You can see it. And that'll just be x, and that'll be in time. So to measure time, we would measure it with a clock. And so I'll draw a little clock here. So starts out here at 0. And then as it moves down here, then it'll be at that'll move some. So if each one of these is, say, a second, then that'd be a quarter of a second. Or if that was a minute, then that would be 15 seconds. And then we can also, like this, we can also make a coordinate for time. The same way, except for you'd do it in 2 dimensions. So I'm going to make a 2-dimensional graph. Actually, I'll go ahead and label this down here. So this is going to be time. And time can be is negative and positive too. And we demark it into something like seconds too. So same way. And then somewhere has to equal 0. We have to have an origin. So then I'll make that 0 right there. Okay. And so that can act as t equals 0. Okay, so I'll save that real quick and we'll clear it out. Okay. So I'm going to make a 2-dimensional graph where one dimension, it's actually 1-dimensional motion with 2 variables. One is going to be x, which is the position, and one is going to be time. And x is going to be a function of time. Okay, so this is going to be x. It's going to be a function of time, this axis here. And we'll want to label this as positive and negative as well. So that'll be the positive direction. This will be the negative direction. Okay, and this will be time here. And that will also have a positive and negative direction. So that's positive, and this is negative. Okay, so we need the origin, so it's going to equal 0 at the origin of each one. So here, so this is going to be x equals 0. We call that x0 equals 0. I can't do subscript, so we'll just have to look at that. If that will work. And then here, this is where t equals 0. Okay. So there, we've defined our coordinate system for one-dimensional motion, where we can see x, the position, as a function of time in relation to time. And I think the easiest way to visualize this is we'll visualize the same bead on a rod, except for we'll turn it sideways so it's going along x. And as time elapses, we'll measure it on here. And you can think of it as if the rod was going horizontally in proportion to time. So I'll go ahead and draw that. And so in our, you can call this a free body diagram or diagram of our situation. We're going to ignore gravity. And since it was horizontal and gravity is vertical, then it shouldn't have an effect on it. And so this is just going to be velocity and acceleration, and we're not going to worry about the forces. And this position can be any function of time. It doesn't have to be linear or anything like that. So that's what we're going to do, just some arbitrary function. I'm just going to go something like that, go below, and then we can come back up and we'll end there. Okay, so that would be something like on the rod and time, it goes something like this. Oh, that's not what I wanted. Okay. Oh. Okay. And back down. Something like that would represent that. Okay, so this is our coordinate system with position with relation to time. This is this type of graph is very important for this type of thing. So next, we're going to try to figure out the speed or average velocity at different points here.